Magnetic waves. In this section, let us look into electromagnetic waves in radio frequency range, which is used in transmitting radio waves. As you already know from Chapter 8, radio waves are electromagnetic waves. As they travel from the transmitter to the receiver antenna, they are largely influenced by Earth's atmosphere, as listed in the table. Ground wave. Ground waves are surface waves which glide along the surface of the ground. This implies that they are influenced by the curvature of the Earth. As the wave travels close to the Earth's surface, it induces a current in the ground. Part of the wave energy is absorbed by the Earth, resulting in attenuation. Attenuation increases with frequency at a very rapid rate. Hence, its maximum range of coverage depends on transmission power and frequency of less than a few megahertz. Sky waves. Earth's ionospheric layer extends from approximately 65 kilometers to approximately 450 kilometers above the ground level. When high-energy UV rays from the sun enter the ionosphere, they collide with atoms in the ionosphere and kick electrons off from them. As a result, the atoms become positively charged. In other words, electrical neutrality of the ionosphere is dislocated due to ionization. As this layer contains ions, it is known as ionosphere. The degree of ionization varies with the altitude and the density of the layer. The ionosphere is divided into different layers depending upon density. Though intensity of UV rays would be large, ionization may not be maximum at large heights, as there are fewer number of atoms there than at the ground level. At the base of the ionosphere layer, there are maximum number of atoms, but the intensity of UV rays is not as large as those at the upper layer of the ionosphere. Hence, here also rate of ionization is not maximum. Sky waves are signals in the 3 to 40 MHz frequency range. Signals transmitted as sky waves get refracted and totally internally reflected by different layers of the Earth's ionosphere and picked up by receiver antennas at hundreds or even 1,000 kilometers away. The distance between the transmitter site and the receiver site, where the first reflected signal is picked up, is known as skip distance. This distance depends upon the frequency of the wave, angle of incidence, and the degree of ionization. Sky wave propagation is the most common mode used by shortwave broadcasters all over the world. Space wave. Space waves travel in straight lines from the transmitting antenna to the receiving antenna. As the waves are in straight-line paths, they may sometimes be blocked due to Earth's curvature. This means that their range is to the horizon. If they need to be transmitted beyond the horizon, the receiving antennae should be high, as you can see from the illustration. Ground waves of low wavelengths or high frequencies greater than 40 MHz are propagated in the line of sight, LOS mode. Minimum line of sight distance is between transmitter and receiver antennas of heights HT and HR respectively, and is given by the following mathematical relationship. dm equals root 2r HT plus root 2r HR, where r is Earth's radius, approximately 6,400 kilometers. The factor dt is known as the radio horizon of transmitting or receiving antenna. dt equals root of 2r HT. Television signals, microwave propagation, and satellite communication are a few examples which use space wave mode of communication. This visual illustrates the above modes of propagation.